I just showed you two examples of two types of batteries. This is what we just looked at was the lead storage, but there's lots of different types of batteries, obviously. They're designed for specific applications, and so that's why they look different. Different types of chemicals are used in them. Some are made such that they're rechargeable, others are not. Therefore, depending on what reactants you use, you're going to have different voltages because the voltage depends on the reactants and the difference in the push-pull power of the oxidation versus reduction when they're paired up. So I'm just throwing this up here to show you that there's a variety of voltages. They depend on the reactants, and also some are rechargeable, some aren't. Depends on what reactants you use and how the battery is engineered, and then all the various uses. And one in particular use is the nickel metal hydride battery that's used in hybrid cars. I just want to point this out as an example. The most common hybrid is the Toyota Prius, and a hybrid means that the car has a gas engine and an electric motor. The electric motor is run by batteries. This is the hood of a Prius, and this is the gas engine, and this is the electric motor. The electric motor is powered by these batteries, and you don't see the batteries here. They're in the trunk. They're pretty big, and so there's not space for everything under the hood. And in a regular car battery, what we just looked at, the lead storage battery, those batteries are recharged by an alternator. So the gas engine, when you're driving and the engine is moving, the mechanical parts also will generate electricity. There's a little electrical generator in there, not unlike one in a power plant. But these nickel metal hydride batteries are recharged in a different way. They're recharged from the braking system. So mechanical energy is actually converted to electrical energy, and that electrical energy directly recharges these batteries. It's really, really cool. All the technology that goes into this type of car. When you're going slow or starting up, it runs on the electric motor, but then if you're putting more of a load on the engine, then the gas engine, combustion engine will kick in and support the electric motor so it can go faster. And also it will support it completely if your batteries do fail. Okay, so I just want to point that out is the hybrid car. And this little the Prius is by far not the only hybrid. It was the first introduced to the US market, but over the years, the demand for more hybrids and for bigger, more variety, whatnot, because the Toyota Prius is pretty small, relatively speaking, but now there's even SUVs that are made as hybrids. This is the gas mileage. In the city, it's 60, and on the highway, it's 51. Normally, for gas engines, you get better gas mileage on the highway driving. But because the Prius uses the electric motor more going slow, and then the starting and the stopping or the slowing is what recharges the battery, so you can get more battery lifetime without having to kick over to the gas. Anyway, that's why it's better in the city than in the highway. And even like down here, these four-wheel drive vehicles, the highway or the city driving is only 32 gallons or miles per gallon, and which is half what it is for the Toyota. But if you're using or if you're driving a big SUV, you'll only be getting like 15 miles a gallon, so it's doubling that. So all these great things with the more efficient engine going straight from the chemical energy to the electrical energy to power these cars. One would think that are most people buying hybrids right now, because not only do they get better gas mileage, so you don't have to spend as much money at the pump, but they emit half the pollutants as a regular combustion engine. Well, if you look at the market share in the US, this is the market share of who's buying what. Hybrids only have 1% of the market share. This is from about 2006 or so. And cars are 44% of the market, SUVs 25%, pickups 19%. So the majority of the market is dominated by cars, SUVs, and pickups. Only 1% of people are purchasing and driving hybrids. And there's lots of reasons for this. The American consumer has sort of been trained to, or conditioned, I should say, really, to enjoy driving in big, comfortable vehicles. A lot of people's self-esteem and whatnot comes from what they drive. A lot of hobbyists, people will spend a big chunk of their incomes on what they drive. So, if a hybrid isn't what you think is making you feel good, so a lot of people aren't going to buy them. But you should be aware of the hybrids, what kind of gas mileage they get compared to cars, SUVs, and pickups. Because as you all will be entering the car buying market before long, you have to remember that gas prices are going to continue to go up as the world economy develops. More and more people, millions more people, need access to fossil fuels, and as the fossil fuel reserves continue to decline and demand continues to go up, you can just imagine the price of fossil fuels is going to go up quite a bit. So even though a hybrid might be a little bit more expensive to purchase initially, to run it, day by day, buying gas is cheaper, and is going to continue to get cheaper. So you want to keep that in mind as you enter the car buying market over the next several years. So finally, I just want to summarize. The question that I asked at the very beginning was, why do batteries look so different? And the reason why you should understand now is that, it depends on the application of the battery. It depends on how much current you need, how much voltage you need, where the battery is going to be used, inside, outside, delicate electronics, or hardy, outdoor vehicle. So you can just see the basic concept is the same, electron transfer. The basic physical idea of separating oxidation from reduction is the same. What's different is the technological advances that have allowed us to have such a variety of portable sources of electricity, basically.